which has the following properties. We have two parallel lines, okay? So we have AC parallel to DF for X and Y. And let's hear. How do you guys think we're going to get X and Y? Ideas. X is over here for all of you who might not see it. There we go, Jason. Y is 40. We need reasons, remember. So Y is 40 degrees. Is it corresponding angles though? Remember, corresponding angles is the one with the F. It's the one with the F. There we go. Thanks, Lisa. So alternate angles. And let's not forget our parallel lines. AC is parallel to DF. Nice. Now, what did you guys say X was? I saw someone say something about X. I hope you knew how to do it. Balisa says 70. How did you get 70, Balisa? Manuel says alternate angles. Oh, nice. Okay, so X plus 70 degrees equals 180. And my reason is this is co-interior angles, right? And of course, we have to write our parallel lines. AC is parallel to DF. So therefore, X will be 180 minus 70, which is 110 degrees. I also hate load shedding, Tisa, so you missed the whole movie just now. Okay. Wonderful. So if those are the options, which one is my correct option? That would have to be number C. X is 110 and Y is 40. A Z. Do you mean for X? So it will be this one, this one. So do you mean like that? If you first do angles on a straight line and then you use alternate angles, then yes, you can do that. All right. Okay, let's go. Let's go, let's go, let's go. Now, quadrilateral KATE is given below. Which statement correctly, most accurately describes this quadrilateral? Okay, let's see what we have. What do you guys think? What shape or which quadrilateral would you say KATE is? And give me a reason. What do you guys think? Yes, square. I think A. Kera Pafaza says C. Manuel says rhombus. C is what? Square. So a lot of people are saying square. Okay. Mike says D. Gabriella just says rhombus. Someone said A, which is a kite. Balisa and Tammy both say rhombus and Balisa says B. Okay, let's look at the properties of this. So all sides are equal, right? All the sides are equal. That's what this means. So can it be a kite? Can it be a kite if all the sides are equal? No. So we've already eliminated option A. Do you see that? So it cannot be option A. That's not possible. Okay, let's see. Now we have a property that is very special over here. The diagonals are bisecting at 90 degrees. Do the diagonals bisect at 90 degrees for a square? For a square? Are you sure? We need to know our properties. No, they do not, guys. They do not bisect at 90 degrees for a square. So this shape has to be a what? Okay, I'll go up now to the first question. It has to be a rhombus. It's okay, Sai. Okay, it just means you need more practice so you get used to it. It's a rhombus. And is it B or D? Let's eliminate now. B says it's a rhombus because we have KT parallel to AE, which is this 90 degrees, and all the sides are equal. D say it's a rhombus because angle K is equal to angle T is equal to angle A is equal to angle E. Are all the angles of a rhombus equal? Let's think about it. No, they are not. So is D true? No. So our answer has to be what? B. So the answer is a B. Okay, wonderful. Guys, let me go up a little bit for all those who wanted to take a screenshot. There we go. Quickly, quickly. Wonderful, guys. Okay, let's move on. Let's move on. Screenshot quickly, a few seconds for this one. Okay. I want to do this one. Let's see if we know our properties and our shapes. I missed you guys too, guys. I wasn't well at all, but I'm feeling much better now, so I'm back. Okay, let's see what we have here. So we have to match the properties with the shape. So first one says a four-sided shape, one pair of opposite sides are equal. This is what's important. One pair, not all pairs, one pair. Oh, we have learned our properties. It is a trapezium. Guys, excuse my handwriting. I told you I'm sitting in a dodgy place. So, a big wow. Okay. Number 3.1.2 says it's a four-sided shape. All the sides are equal. The diagonals are equal. And all the interior angles are equal. Nice. You see, Sai, you do know your properties. This has to be a square. It cannot be a rhombus because in a rhombus, the angles are not all equal, guys. Remember that. And the diagonals are not equal. So it cannot be a rhombus. Woo! A four-sided shape with perpendicular diagonals and two pairs of adjacent sides are equal. Two pairs of adjacent sides are equal. It's a kite because adjacent means next to each other. So that would be a kite. Oh, you guys are on fire. Guys, I like when the messages just stream in and they just like, beautiful. Okay. 3.1.4, it says a three-sided shape with three equal angles. Nice. It's an equilateral triangle. Triangle. And the last one says a four-sided shape with equal diagonals that bisect each other, but the diagonals are not perpendicular. The diagonals are equal, but they're not perpendicular. Think carefully. Are the diagonals of a parallelogram equal? Are the diagonals of a parallelogram equal? Now we change to rhombus. Are the diagonals of a rhombus equal? No, they're not. Oh, hectic, Sai. Thank you, Abu. It's a rectangle. Guys, only two shapes have equal diagonals. Rectangle. Nice. Well done, guys. Well done, well done. How are we feeling? We good? Thumbs up, thumbs down. I think we're back on. We're on fire. We are wonderful. Beautiful. Emmanuel's like flabbergasted. There we go. I see your thumbs up. I love it. Okay. Now, also, Simone, I finally figured this out. I looked at it and I was like, how did I miss that? But I figured it out.
You did? I would
You
love to see it.
Okay, guys. So we have rectangle, one rectangle, and a bunch of triangles, okay? So we want to know, prove with reasons that this triangle is, what do these three lines mean? Let's see if we know. What do these three lines mean? Yes, Sinesihle.
Hi, ma'am.
Hello.
How are you, ma'am?
I'm good, and you?
I'm good, ma'am. So, ma'am, you see, WTE is the same as EWDS.
EW. What?
TW.
DS. What do these three mean? What do the lines mean?
Oh, ma'am, I think it's when they're similar, ma'am.
Yes, it's similar. Does similar mean they're exactly the same?
Yes, ma'am.
Ooh, think about it. What does congruent mean then? What's the difference between the two?
Oh, ma'am, it's not the same, ma'am, but they do look alike a bit.
Okay, so thank you. Abu said it so nicely. Similar means they are similar, but they are different sizes. So it's either a shrinking or a growth of the same shape. Exactly the same is congruent. Okay, guys? So do not confuse them. Yes, Tammy, the sides are in proportion. Okay, so they have the same angles, but different sides. So you guys have already told me the conditions we need to prove similarity. We either prove that all the angles are equal, so angle, 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 or we prove that the sides are in proportion. So which condition do you think we're going to use out of these two to prove whether these are similar? What do you guys think? Yes, Palisa. I see your hand is up.
Ma'am, I think we're going to use angle.
Nice, Palisa. Okay, give me the first angle that's equal in those two triangles. Maybe I could highlight the two triangles so you know what we're talking about. So we're on this one, guys, and this one. Okay.
Ma'am,
What's the first
I
angle?
think WT equals to SD.
2SD, but those are sides. Remember, we're using angles.
Oh, yes, ma'am. So, ma'am, we're going to say T1
T1
equals to D2.
is equal to D2. And in my reason?
Given.
Given. Nice. Thank you. Do we see any other angles that are equal? Yes. X is not equal to Y. Remember, that is a rectangle. Someone said T1 equals D2. Yes, that is true. X is a side, guys. Remember, X is a side. It is not an angle. Remember, we said we have to use angle, angle, angle. We cannot use sides because we don't know what X and Y are. T1 is equal to D2 because it's given. Look here. This means it's 90 degrees, which means they're equal. Okay. Now, guys, this took me a while to figure out. But what do we know about a rectangle? There's a reason they gave us this rectangle. What do we know about a rectangle? Guys, tell me something we know about the sides of a rectangle. Okay, everything is 90, yes. What else do we know? Equal sides are opposite, yes. Okay, let me do that. 1, 1. And then, what else do we know? There's one that I haven't said. Oh, Tapang, you're onto something there. Parallel sides. Okay, so we have parallel lines, right? So we can use these parallel lines to get another angle to be equal. Does anybody else see it? It took Simone and I a while. We were both like, what? Where is this? Okay, so this was a side of a rectangle that is just made longer. Do we see that? And now here we have another side of a triangle. And if I take this there and I do this, which shape are we seeing here? The F. Do we see the F? So which two angles are equal, guys? Oratile, this was a bit challenging. I'll even admit that myself. Which ones are equal? Palisa? It was in the face. Yes, Palisa?
Hi.
Hello.
I think, can you hear me?
Yes, I can.
So, ma'am, I think it's E1
E1.
is equal to D2. No, D1.
No, remember, look where the yellow is. Yeah, I think the red is confusing. Look where the yellow is. Can you
Yes,
see
ma'am.
the F?
Yes, ma'am, I can see the F.
So what's the second one?
It's E2.
No, look at the other arm of the F. Here's the first one, right?
Yes, ma'am.
So the second arm, it's here, isn't it?
Yes, ma'am.
So then E1 is equal to?
D1.
Is equal to S. There.
Oh, ma'am, I couldn't see the S.
Is equal to S. Remember, we are in these two triangles. Do you see?
Oh, yes. Yes, ma'am.
Yes. So E1 is equal to S. And what's my reason?
Given.
Corresponding angles. Remember, we're using the parallel lines.
So, ma'am, when you're using the fun reasons, you can't say given.
No, you have to say which one you're using. So you have to say, is it parallel, is it corresponding or alternate or what? And which lines are parallel. So my parallel lines are, thank you, Abu. AS is parallel to TA. Oh, that was nice. Thanks, Valisa, for helping us find that one. Now, guys, I drew that F because I see a lot of you are still struggling to see it. Okay, except in our case, it's a little bit of a slanted F like that. So this angle and that angle are equal. Okay, this F is just upside down. So now we have managed to get two angles equal. All right. Yes, that F is going through a limit. Let me rub it out. Oh my goodness. Okay, now. Oh, that's a T. I was gonna be like, what's this? Now, third angle, guys. If two angles in two triangles are equal, what can we assume about the third one? What can we assume about the third one? We're not listening. If we don't finish on time, I will skip the brain break. Thank you, Sai. Why do you think we can assume it's equal, guys? Listen to my question. I'm going to repeat it. We proved that this angle is equal to that angle, right? And then we prove that that angle is equal to that angle. Now, my question is, why can we assume that W is equal to E2? Why do you think we can? No, we're proving similarity, so we can't use it. But why can we assume that the third one is? Yes, Emmanuel. They add up to 180, don't they? They both add up to 180. So if this is 90 and that's 90, and this is maybe, let's say 60 and that's 60, then the last one will have to be 30 degrees in both triangles. Can you see that, guys? So then you're going to say angle W is equal to angle E2 because of, you don't even have to show sum of angles of triangle. Do you see, guys? So please remember that if you prove two angles in a triangle equal, you can assume that the third one is equal. Okay, let me write it down. If you prove two angles in two triangles equal, you can assume the third will be equal. But do you guys understand why? Okay, let's take hands, guys. Let's take hands. It cannot be wrong, Sai. Okay, let's give values to these angles so I can show you why it can't be wrong. We already know this is 90, right? So that's 90. Let's give this a size. Okay, let's give E a size. Let's say E is 60. Okay, E is 60, which means S has to be 60 because we just proved that they're equal. Are you with me, Sai? So let's find W in this triangle. So therefore, W will be 180 minus 90 minus 60, which is 30. Okay, that's in this triangle. Now let's go to this triangle. E2 will be 180 minus 90 minus 60, which is also 30. Okay, so the sum will always have to add up to 180. And if you are subtracting the same amount, you will end up with the same answer. Do you see what I mean, Sai? So if you prove two of them equal, the third one has to be equal. Okay, this is why we're doing problem solving, guys. There we go. Zoe gets it, Sai gets it. So in a triangle, it's like in a quadrilateral, guys. You know that the interior angles of a quad add up to 360, right? If you can prove that the three angles are equal, the fourth one has to be equal because they will always add up to 360 degrees. Look here, we are minusing the same thing, 90 and 60. 90 and 60, you always end up with the same answer. So therefore, if I prove, for instance, we prove that two are equal, we can then say, therefore, the last one has to be equal because the sum of an interior angle of a triangle will always be 180, and therefore third angle is equal to third angle. Okay, wonderful, guys. Now we've proven three angles are equal, and now we can confidently say, therefore, triangle WTE is similar to triangle EDS, and my reason is angle, angle, angle. Okay, someone just sent me a message saying they still don't see the F. Okay, I'm gonna try and do something here. Oh. Okay, let me see if it's even possible to do that thing. View, maybe if I say view, reset to zoom, format, let's go, rotate. Okay, I've rotated the shape. Nobody panic, okay? Nobody panic. I just want you guys to see the F. It is over there. Now it's just facing backwards. Can you guys see it better? Can you guys see it better? So I've rotated the shape. Can you guys now see the F? Wonderful. There we go. So it was just upside down and facing the other way. So that made it a little bit hard to see. But now that I have rotated it, can you now see the F? Now let me put it back the way it was. Okay, so therefore it was over there. Whoop, whoop, whoop. There we go. Okay, wonderful. Now let's take a screenshot There are no parallel lines, Avril. That's why they told us it is a rectangle. You see, so we use the properties of a rectangle. We know that sides of a rectangle are parallel. So this side is parallel to that side because this is a rectangle. You see? So they had to tell us that it was a rectangle. We didn't assume that the lines were parallel. They had to tell us. Why can't we say WE is equal to ES? Because we don't know. Okay, we don't know. Yes, Abu, if you don't read the sentence before the sketch, you're gonna miss a lot of things. We like doing that. You guys are used to having a sketch where stuff is drawn on. Like for instance, your teachers will do this for you, but sometimes they just give you a plain sketch and they give you the information above. So if you don't read, there goes your marks. Okay, are we good? Screenshotters, I hope you screenshotters. Okay, we'll come back. We'll come back. Okay. Now, what does this symbol mean? What does this symbol mean? Thank you, Sai. Congruent. So that means that the triangles are exactly the same. Same size, same everything. Okay, so now we have to prove that these two triangles that are facing one another are congruent. Okay, let's get started. Okay, Luetu has given us an idea. Luetu says side angle, angle, question mark. What are the other conditions we can use? Okay, actually, let's start. Thank you. Sai has started. Sai said AC. Nope, we don't know that AC is equal to that. Let's start with the conditions, guys. What's equal to what? Vert up in the middle, but that's not part of the triangles we're looking at. So we're looking at these big ones. Okay, guys. We're looking at these ones. So this one over there. And the other one is this one over here. Ooh. Over there. Narisha? Yes, Narisha? It's here.
Okay, ma'am. So angle A is equal to angle D, given.
How was it given? Is it given? How do we know when something is given? It isn't. Remember, we can't assume. They might end up equal, but now we have to use what's already on the sketch. Can you see?
Yes.
Okay, so what is given? See, Tammy is helping us.
AB is equal to BC.
And that is given because they wrote lines on it. Do you see?
Yes.
These two little guys over here means that they're equal. And my reason will be given. Wonderful. Okay, so we have a side. What else can we do?
Angle B is equal to angle C.
Something. There we go. Angle B is equal to angle C. What's my reason?
Given.
Given. It was given. Okay. So we have a side and an angle. Now what's going on? It's here. Anyone have an idea? So we either prove one side or one angle. Yay! AC is coming. Oh, BC, sorry, not AC. BC is coming. Okay, you had the vision. You had the vision. BC, the one at the bottom, is because they are common. It's not BC, it's the one at the bottom. It's this one. You see it? You see it? Both triangles have that side.
Yes, ma'am.
Nice, guys. So therefore, triangle ABC is congruent to triangle DCB. And what's my reason, guys?
Side angle.
Side angle side. Why do we write it as side angle side? Do you guys
Because
know?
there's one angle and two sides.
Okay, but it's not just one angle and two random sides. I want to see if anyone knows. There we go. Luetu knows the angle is between the sides. Do you see?
Yes.
The angle we're talking about has to be between the sides. That's why we say side angle side, because it's, let me show you. It's the side, the angle, and the side. So it's not this angle that's there randomly. Okay, it's the one in between. Woo!
All right.
Oh, thank you so much for doing this with me. Love it. Okay. Okay, guys. Okay, let's have a very quick brain break. Very quick, very quick. Would you rather, hands up, would you rather be able to control fire or control ice? Let's hear. Palisa. Palisa, are you there?
Ma'am, I'd rather we could control fire.
Fire, you wanna pay?
No, ma'am, I won't burn because I can control fire.
Oh, that's true. So you wanna burn other people? Oh my
Sort of.
hectic. Can I give you a list? I'm kidding. I'm kidding. Okay, let's hear who's next. Sia, are you ready for your question? Sia?
Yes, ma'am.
Okay, let's see. Would you rather be able to turn into a giant or be able to shrink to the size of an insect?
I think it'd be better if I was able to shrink to the size of an insect.
Shrink. Why don't you want to grow into a giant?
Mainly because when I grow, it'll be more of a problem for me and everyone else than when I shrink.
That is true. Who named themselves Miss Cat? Guys, there's a lot going on in this class. What's going on? Hectic. I saw that just now. Okay, I also don't want to be a giant, guys. I don't want to be a giant. Please. Yes, guys, I haven't renamed myself. So there's another Miss Cat in here. I'm not Miss Cat today. I don't know what's going on. Hello, are you there?
Yes, ma'am.
Hello, would you rather wear patterns all the time or very bright, solid colors?
Ma'am, I would rather wear very bright, solid colors.
Hello, you wanna? I can't.
Ma'am, I don't want to look like a Popeye every day. Oh,
With patterns. What if they're nice patterns?
that's not nice. Oh,
And guys, those who say patterns, it's head to toe. So your shirt must be patterned, your pants must be patterned.
Exactly, ma'am. No one's going to take you serious. Oh,
Color. You must be line, round, everywhere. Oh, Tammy has a point. Wear patterns that have black. Nice. Okay, let's see. Do I have another one? I think I do. Asekona, are you ready? There we go. Asekona, you there?
Yes, ma'am.
Would you rather have a permanent unibrow or no eyebrows at all?
I'd rather have a permanent unibrow.
Mtoko, a unibrow is when you have one eyebrow, a very long one, from left to right. Let's like, no eyebrows, Baba. I'm so dead. I am so. Who said you couldn't style it? Abu is onto something. Abu, are you speaking from experience? I feel like you are. I feel like you're speaking. Anya, tell us, unibrow or no eyebrows?
No eyebrows.
Anya, they said you can style it.
You can just draw them on.
No, I like
I want
uni.
And look like Squidward.
Oh my goodness, literally you will look like Squidward. I didn't think of that. Oh my goodness, how do you guys think of such? How do you guys think of such? I actually can't. I'm done with you guys. Okay. Wonderful, guys. Our lesson was late, so we have to move on quickly. Okay. In the figure below, we have the following dimensions. We have 90-degree angles. And what I want from you guys is to find the side YZ. YZ. Okay. Let's find YZ. Oh, Benson from Regular Show, yes. That is very inappropriate. Okay. But it's fine. Simone will handle it, guys. Don't worry. Okay, Valisa. Come on, guys. We missed 15 minutes of our...
Okay, ma'am,
Okay.
so I can try. So, ma'am, I know that YT is 13 because the top angle is also 13. So, ma'am, it's Pythagoras' theorem, right? Yes.
Lot going on. Okay, let's move on.
So, ma'am, we're gonna then say YZ squared equals to YZ squared equals to ZT squared plus Y
But
T
look
squared.
carefully. Look carefully, Valisa. Which one is your hypotenuse?
And then, ma'am, we're gonna say,
Valisa,
ma'am, should I carry on?
which one is your hypotenuse? Be careful.
Yes, ma'am.
So, why is
Ma'am, the hypotenuse is opposite the 90 degrees, which is 13.
Yes. So what's Z squared plus TZ equals YT? Do you see?
Oh, that we can, oh, okay.
Yeah. So the one we want is YZ squared plus how much is TZ?
Yes, ma'am.
5 squared equals 13.
And then, ma'am, yes, ma'am. And then, ma'am, we're gonna say 5 squared is 25 plus 13 squared is 169.
Okay.
Equals to 169.
Okay, minus 5.
Then, ma'am, we're gonna say YZ squared equals to 169 minus 25,
Which is
which is 144.
wonderful. Okay, and then
144.
okay, what's
And then,
next?
ma'am, we're gonna square root both sides. And then square root cancels square root, which, and then left with YZ equals to 12.
Wonderful. Beautiful. Thank you very much. That was beautiful. Okay. Let's move on. There we go. Okay, let's move on. We need to do this challenging one, guys. You know I love you guys, right? Let's do this one. You know I love you guys. You know I love you guys. You know when I say I love you guys. Okay. Yes, I want to extend the time. Guys, do you guys mind staying like 10 minutes more, please? Thumbs up, thumbs down. What do you guys think? Because we missed quite a lot of time in the beginning of the lesson, please. Thank you, guys. If you have to leave, then it's okay. I understand. Okay. If you have to leave, it's okay. But I'll be staying here 10 minutes more because we missed quite a bit of time. Okay. Whoever is Miss Cat, I'm watching you. There we go for screenshots. Few seconds. Okay. Wonderful. Let us see what we have here. Okay, up there, I have snipped off a letter and it was D. This is D. So ABCD is a parallelogram. Okay, so they obviously gave us some sort of information. We're obviously going to maybe use the properties of a parallelogram. Let me highlight it. Okay, AE, where's AE? The AE bisect BAD. Do you see that they've already written that down for us? That means A1 is equal to A2. Okay, wonderful. C is equal to 60. They've written it down for us. And AE is perpendicular to EB. They've shown us the 90 degree. B2 is equal to that. D2 is equal to that. Calculate the size of E3. Where is E3? Let me first find E3. It's over there. Whoa, this is interesting. It's over there. Someone says A2 is equal to B1. We don't know. Okay. We don't know. What do you guys think, guys? You see where E3 is? What do you guys think? How do you think we're going to get to E3, guys? Anyone? Nope. Okay, guys, we are doing this now. Never mind natural sciences right now. No ideas. Let's look at where E3 is, guys. Let's look at where it is. Shouldn't we calculate for X first? Okay, we can. What do we know about the opposite angles of a parallelogram? What do we know about opposite angles of a parallelogram? They're equal, isn't it? They're equal. So am I right in saying that C, angle C, which is 60, is equal to the whole of angle A? Did you guys agree with that? Yes. So therefore A1 is how much? A1 is how much? 30. Because I have to add up to 60, isn't it? So this side is 30 and that side is 30. Okay, are we good so far? Is everybody with me? I hope so. Now, tell me, this triangle at the top, ADE, what type of triangle is that? Oh, but we don't know if it's a trapezium. We have to be told it's a trapezium. It's an isosceles. It's an isosceles, guys. It's an isosceles. If it's an isosceles, what does that make D1? What's the size of D1? Can you guys see where I'm going with this? D1 will have to be 30. Now I have two of my angles in the blue triangle. If I find E2, what can I use it for? If I find E2, how will it help me with the question we are doing? angles around a point. Thank you, Emmanuel. And I think it's time that we write down what we are doing. Okay. So we said angle A, the whole of angle A is equal to 60 degrees because they are opposite angles of a parallelogram, right? Therefore, A1 is equal to 30. Okay, wonderful. Then we said D1 will then also be equal to 30 degrees because these are angles opposite equal sides. Okay, I'm just writing down what we did. Okay, so then E2 plus the 60 equals 180 because it's interior angles of a triangle, right? Therefore, E2 is 120 degrees. Okay, now how are we going to use that to find E3? Remind me again. How do we use it to find E3? They add up to 360. Thank you, Tammy. And there's someone else who said that. So then 90 plus E2, which is 120, plus E3 will have to be 360 because it's angles around a point. So therefore, okay, I have to write up here. Therefore, E3 is 360 minus 90 minus 120, which is 150 degrees. Beautiful. Beautiful. You guys get what just happened? How are we feeling about that one? We good with one? You good with number one? Okay. Okay, Sai, where did I lose you? Let's go back. Where did I lose you? At D1. D1. Okay, Sai, maybe it's the blue highlighter that's messing up everything. Okay, Sai, so we said A1 is 30, right? Do you see these? That means, yes, we do still have a quiz. That means this is an isosceles triangle. That's why we said A1 has to equal D1. Do you see that? So once we have that, we can find E2 using the interior angles of a triangle. And then we can find E3 using angles around a point. Okay. Then it says, then calculate the value. You're welcome. Calculate the value of X. Yes, Taylor. Hello.
Hey, ma'am.
Hello.
To figure out the value of X, you're gonna use the 150 from E3 plus 3X plus 30 plus 2X plus 20 plus 60 equals 360.
Nice, because they are?
Because they all add up to 360, ma'am, because they're
Interior angle of a quadrilateral. Plus E was what? 150 equals 360. And my reason is interior angles of quad. Okay, did you actually do it? Do you want to continue?
yes, ma'am.
Okay, okay.
So you would say 2X plus 3X on one side equals to 360 minus 20 minus 30 minus 60 minus 150.
Okay.
Which is equal to 100.
100. Okay.
Yes, ma'am. And then you would say 100 divided by 5 and 5x divided by 5, which therefore means that x equals to 20.
Beautifully done. Gorgeous. I love it. Okay. Nice, guys. And then the last one, I think, is the more simpler one. Prove that D2 is equal to 90 degrees. How are we going to do that? Anyone? Prove that D2 is equal to 90 degrees. Taylor's back. Yes.
Ma'am, since you figured out x, you're gonna put 2x plus 20, and you're gonna add the 20 degrees into the x position.
It's D.
You got that angle.
It's D, remember? So it's 3x plus 30.
Oh, 3x plus 30, sorry.
There we go. So you're going to say 3, 20 plus 30. What's 3 times
Which is
20?
equal 60 plus 30 equals 90.
Yay!